histogram shows each interval as a bar. The heights of the bars show the frequencies or relative frequencies of values in each interval. I have displayed for us a dot plot, you know, like here was a dot plot, and then what they did was, you see on the dot plot, here's everyone that was in between 0 and 5, you know. They just kind of stacked those dots up, you know. It's like, oh, that's everybody that was between 0 and 5, and then they turned it into this. Histograms are most useful with blank data sets. That correct answer is large data sets. If you have a large data set, histograms are very useful. Our data set today about text messages was not large. There was only 13 pieces of data, you know. So histograms would be more useful with large data sets. And the intervals are sometimes called the bins or the buckets. These intervals are sometimes called the bins or the buckets. I want to add some more notes to this at the top, because in like the second lesson, we made bar graphs, and like this is a histogram. They're almost the same thing. Would you believe that histograms, you know, please put a little note maybe like right here, have no spaces. No spaces between the bars. Like the bars touch each other, you know. Histograms have no spaces. And here's kind of the truth of how it should work. Probably got to put some notes off to the sides. Bar graphs are for categorical data. Categorical data. And histograms are for quantitative data. Histograms are for quantitative data. The data that we collected, you already told me, was quantitative. We just said the number of text messages. Now, could you imagine if we made a bar graph where it's like, okay, where did these messages come from? Did they come from Snapchat? Did they come from your actual text? Did they come from Facebook Messenger? Did they come from TikTok? You know, it's like those are categories, right? We would have to make bar graphs with that, you know, these little categories. So cool. All right, so here is a table right here. What is the table about? The age of the first 45 U.S. presidents when they took office. Make a frequency histogram of the data starting at age 40 with your group in the applet, with 4, right? So we're going to go to the applet. So like here's what I want to do. When I say with a group, one person can read the data to someone else, the other person can put it in. So it's not going to be a collaborative group. You're going to go back to this. So if you want to go back to Canvas, you know, is probably the easiest spot to get to it. And on the agenda, there is the applets. You might even want to just bookmark that page because we're going to use it so much. So when you get to the applets, if you just bookmark this page, you know, it'll happen a lot. And I want you to do the one quantitative variable single group. Like you can work with a partner where you don't all have to make it. If one of you reads the data and the other one like enters the data, that's fine by me. Our variable name is age of first 45 U.S. presidents at inauguration. Spell it right, it's on your worksheet. Or when they took office. Let's do that. When took office. And then what you got to do is just input the data. You just leave a space. Instead of putting commas, it says you put your data in like this or by commas. I'm just going to like put it in. So 57 space 61 space. Just keep going. Somebody read it to the other person, and you can enter it. Order doesn't matter what order you put it in. It'll sort it for you, right? So I believe I got them all typed in correctly. Of course, we could make typos. Right here, it shows you that you got 45 of them in, right? So I'm going to change it to a histogram. And I believe it said make your interval with 4. Am I right about that? It says use intervals of 4 starting with age 40. So interval 4, boom. And it automatically started with 40. Boundary value, I believe that's your 40 right here. So if we hit that, there you go. Do intervals of 4. And when they tell you the boundary value, that's where you start at, right? So we're going to start at 40. You guys cool with that? Okay. So I got her all snipped out over here also. It says describe the shape of this. So let's go with the shape. What do you think? Fairly symmetric, skewed right a little bit, skewed left a little bit, skewed right a lot, skewed left a lot. Discuss with neighbor. What do you think? I did say, the class thinks they're fairly symmetric. I'm not going to argue with it. I did say that it was slightly skewed right, Like, I think both of those would be acceptable. Obviously, on your homework program, it's a drop-down menu, so choose the one that works the best, But if you say fairly symmetric, I am totally down with that. The other thing we should start getting used to is how many peaks it has. This is a single peak. Are you guys cool with that? And there were no real gaps in that data. Between the bars, there was not a gap. Cool? Cool with that? It says what percent of the presidents took office before the age of 60? Well, let's go back to this. Let's see if making a relative frequency graph is going to help us with that. So let's change frequency to relative frequency. And then if you hover over these guys, we just got to kind of add them up in our calculator. You see that 4.4% were in here, 8.9% were in there, 20% were in there, and 24.4% were in there. And same thing here, we're going less than 60, right? Remember, 60 doesn't count in this bar. 60 counts over here, right? So if you add up all those percents, because I switched it to a relative frequency graph, what did it all add up to be? What'd you get? 57.7. Interesting. I wonder if we can do that. Is that what you all got? I'm looking for the number of 75.6. Did you get 17.8, right, because this bar counts, plus 24.4, plus 20, plus 8.9, plus 4.4? What does that add up to be? Yeah, the 75.6 or 75.5. That's what I did. The other thing you could do, if you didn't want to do that, is sit here and count all your frequencies. Would you believe this is 2, this is 4, this is 9, this is 11, and here there is 8 of them? So if you added all those up, that's 34 of the 45 presidents, which would give you that same percent in that case. So you could do your relative frequencies, since it's there on your chart. You could find the number in each category, and then totally divide by 45. You guys okay with that? Cool. That's one little histogram. I believe that we are done with that. If you wanted to shut the computer if you're kind of dying, I don't care if you keep it open or not. So we got that. Let's check out this: burning fossil fuels in power plants and motor vehicles emits carbon dioxide, which may contribute to global warming. In what percent of countries did emissions exceed 10 metric tons per person? So technology has failed us. We don't have this on our computer now, right? So when they ask us the percents, this is not a relative frequency graph. What we need to do is go on our paper and count up how many are in each bar. So let's do that for every one of these. Let's just label them all. How many are in each bar? Just put them at the top. That's what I got with all my numbers. Count them up. How many total countries? Because they don't tell us in the instructions how many there are, so we've got to count them all up. What do all those add up to be? I got 48 as well. So 48 total. It says, in what percent of countries did emissions exceed 10 metric tons? So let's talk about ones that are bigger than 10. Here's 9 to 10 right here. This last bar right there, that doesn't even count with the 10, so we need these. There's 1, 2, 3, 4, 5, 6 of them, right? There's 6 of them here that were bigger than 10 metric tons, so 6 out of 48. And then if you change that to a decimal for me, and then we'll go to a percent. Doesn't your calculator spit out 0.125? And then to change that, they'll probably say 1/10 of a percent like they do. How do you feel about 12.5% on that guy? You guys cool with that? When it's on your computer, they already show you that information. Otherwise, you got to count them up on the bars. Let's describe the shape. Fairly symmetric, skewed right, like a lot or a little, you know. Skewed left, like a lot or a little. What do you want? Yeah. So let's say like drastically skewed right. You know, like isn't it a huge deal, you know? So like drastically skewed right. Drastically skewed right, or some sort of word. You'll see it on your drop-down menu. It's like, yeah, was it like slightly skewed right or drastically skewed right? How about peaks? How many peaks does she have? So we'll say single peak. Any gaps in the graph? Yep. So gaps. So we'll list that. Gaps. Boom, boom. So this is probably, remember, this is 9 to 10 right here. So where the heck is this gap right at from? So 10 to 11. And then from 13 to 14 probably. And then from 15 to 16. Kind of cool with those 3 gaps in the graph right there. What do you think about outliers? Would you believe, I know we haven't mathematically figured out if there's any outliers. Would you believe, yes or no, do you feel there's any outliers? I'd say it's possible. It's possible. Isn't most of the data like right here, you know? So like, wouldn't you think like maybe these last 2 nuggets could very likely, like we'll do the math another day, you know? One day we'll figure out how to do the math, but these are pretty, I mean, it's like, maybe even all of those are outliers. Who knows, you know? But I would say it's very possible to get outliers, you know? It's very possible, like those are possible at the end. So your homework program will be specific, but I would just say there are possible outliers. Cool, there are possible outliers. And you can see here, instead of drastically, I said extreme right, so that might be how the homework program writes it. So drastically skewed right, extreme right, whatever. Let's talk center. There was 48 total dudes here, right? Who's in the middle of that? 48 divided by 2. Who's in the middle of that? 24. Hang with me, guys. We're almost there. Let's go find the 24th term. Here's 12 of them right here. And then if I add 5 more, isn't there 17 terms? Then there's 4 more. So 12 plus 5 is 17, plus 4 more is 21. And then add 5 more, that's 26 terms, 27, 28, 20. Would you believe the middle is in this bar right here? This is where the 28th term lies. I found that by adding up my bars until I got to 28, you know. So this guy, the center, is in which bar? Where would that be? There's 3 to 4, of 5 to 6, you know. So I would call that, you know, center is in 3 to 4, 4 to 5, my bad. 4 to 5. And then whatever the label is, so it's metric tons per person. See, your homework does a kind of tricky job with their drop-down menu of like, okay, you know the answer is 4 to 5, but what's the right label on it? You know, it's this label per person. And then how about the variability? That's the easiest one, in my opinion, to find, you know, the variability. The shape's pretty easy also, but the variability, just tell me your low. The low is right here. This is the lowest column, right? So it goes from 0 to 1. Isn't that the lowest column right here? To the highest. Which one is the highest column? This guy. What is his boundaries right here? 17 to 18. And then we'll throw that label on it again, metric tons per person. That's the variability. You go low to high. Cool. Just reading data and a histogram today. And then the last one. Maybe not. There's 2 more. My bad. Sorry. Got ahead of myself. All right. These graphs, these are called like a side-by-side histogram because they're like on top of each other. They're talking about data about students who graduate from high school. Students who graduate from high school, earn more money than students who do not graduate from high school. So let's check this out. This whole side is about, okay, did you graduate from high school? Can you see the top graph? Is people who did not graduate from high school. I'm going to do that in red. It's red, like stop sign. Green is people who did, right? These people here graduated from high school in this bottom graph. Up top, those people did not graduate high school. Let's talk about the shape. Both distributions are blank and single peaks. Let's just talk the shape. What do you think? There's that graph, there's that graph. What would you say? Both graphs are what for shape? Skewed right. You know, both graphs are skewed right. Outliers. It says there are some possible high outliers in the blank distribution. So let's just talk top or bottom real quick. Which graph do you feel has the outliers? Top one or bottom one? The bottom one. Okay. What is that one about? Of course it's about the people that said yes. Yes, they did what? What did they do? They graduated, right? So is it cool that we could call that the graduate distribution? You know, there's some possible high outliers in the graduate distribution. Let's find the center. Ooh, this is going to be nice to find the center because here's my question. Is this a frequency histogram or a relative frequency? Frequency counts numbers and relative frequency is about percents. So isn't this a relative frequency? When you've got frequencies, where's halfway? I mean, the whole thing's 100%. Where's halfway? How much percent is halfway? 100% is all the way. What's halfway? 50%. Cool. 50% is halfway. So check out this very first bar on this top graph. You know, how much data lies in this first bar percentage-wise? 60% of that data. Would you believe that more than half of the data is just in that first bar? Like we want to know, where does 50% take off? Well, it's in this guy. So this is the non-graduates. You know, where's the center at? In this column right here. Holy cow. What does this mean? 0 to what? 0 to 10,000. From 0 to $10,000. I don't know when this data was taken, but the center of this non-graduate data happened in the $0 to $10,000 income. Those people did not graduate high school. That is where their income was located. Let's see if you can find where the 50% mark is in this guy. How much is right here, percentage-wise? 30%, right there. I need to get up to 50%. So here's another 20%. How much is that already? Boom. Would you believe it happens in this bar right here? Happens in that bar. That's where the 50% of the data happened. So, I switched them around on accident too. On my answers, I have them backwards. So let me just go back to this. It was between the 10 and 20,000, right? The 10 and 20,000. Which one had the larger center? The graduates or the non-graduates? Which one had the larger center? This center is between $10,000 and $20,000. This center is between 0 and 10. Isn't this guy bigger, right? Isn't 10 to 20 bigger? So that is for the graduates. Indicating that they typically have a higher income in this sample. And then would you try the variability? Just list low to high in each one. Tyler, when we're done, we're going one more from. Graduates, low was 0 to 10,000. And then the high, like 140 to 150,000. That's the graduates. That's down here. Get your low to high on the non-graduates. Low to high. Low to high. So low was 0 to 10,000 on here. What's the highest in these people surveyed data-wise? What's the most that they made? Looks like 50 to 60,000. Are you guys feeling better about SOCV, like the shape, the outliers, the center, the variability kind of stuff? Let's try one more of those guys. All right, last one. Read it, and I'll see if we can figure out what they're about. Top graph about people in each age group that live in Australia. Bottom graph, people in each age group that live in Vietnam. Here's their total populations. Here's Australia. Boom, that's how many people that live in Australia. Here's Vietnam. Boom. Let's talk about those two numbers. Close or not close? 22 million, 94 million. Are those not very close? They asked, why did we use percents rather than counts on the vertical axis for these graphs? Like, why did they make a relative frequency graph instead of this? It's because these two numbers are not close to each other. The data is so, like, different. So, however you want to word that, I would say because the groups have much different sizes. Like, when you're comparing groups that are just so small to so large, the data is not going to be accurate. If we did our text message between us 13 people that did it, and then did it to the whole school, you know, which has got like 1,000 people, wouldn't you believe that those would look so different than each other, you know, because the more data that you can put in there, the more accurate the graph. So let's compare these guys. Let's just do them out loud, right? Let's do them out loud. Shape. Is there anything similar to shape, or are they different? They asked what are the differences. So let me ask you that. Are their shapes same or different? What would you think? Yeah? Let's just describe them real quick out loud. What would you, let's go to the easy one, the purple one. How would you call the purple one? Skewed right? Are you guys okay with that? This one, I believe Calvin asked about that last time. It's like, what would you call it when like all the bars are almost at the same height? Except for these few, right? You know, but would you believe that this one has just this big hump, you know, they're all level. That's what we'd call fairly uniform, you know. Yeah, I know these are a little smaller down here, but this one is a lot more uniform. So let's maybe put that, you know, if you want to. You don't have to write it in such a sentence. You could say Australia is uniform. Australia is uniform. Vietnam skewed right. Like Australia is uniform, and Vietnam is skewed right. You guys cool with that? That's pretty much their differences. What I'd like to do is let's get some homework done.